From ancient myths to modern science fiction, humanity has always been captivated by the idea of teleportation. The concept of moving from one place to another instantaneously has been a tantalizing dream for generations. In ancient times, stories of gods and mythical beings who could traverse great distances in the blink of an eye filled our imaginations. These tales were not just flights of fancy, but reflections of our deepest desires to overcome the limitations of our physical world. The ability to travel vast distances instantly, without the constraints of time or space, has been a recurring theme in our stories and dreams. In modern times, science fiction has taken this idea and run with it, presenting us with visions of a future where teleportation is as commonplace as air travel. Movies, books, and television shows have all explored the possibilities and implications of such technology, sparking our curiosity and fueling our imaginations. Imagine for a moment stepping into a teleportation device and in the blink of an eye finding yourself on the surface of another planet. The sheer wonder of such an experience is almost beyond comprehension. No longer would we be bound by the slow crawl of conventional travel. Instead, the universe would be at our fingertips, ready to be explored in an instant. No need for cumbersome spacecraft, no risk of cosmic radiation, no years spent in the void. The challenges and dangers of space travel would be rendered obsolete. Teleportation would offer a safer, faster, and more efficient means of exploring the cosmos. The dream of visiting distant planets and galaxies would no longer be confined to the realm of science fiction, but could become a tangible reality. This dream, once relegated to the realm of fantasy, has begun to capture the imagination of scientists and engineers. Researchers are delving into the mysteries of quantum mechanics and theoretical physics, seeking to unlock the secrets of teleportation. While we are still in the early stages of understanding, the progress being made is promising. The boundaries between science fiction and science fact are beginning to blur. While still firmly in the realm of theoretical physics, the concept of teleportation is no longer entirely outside the bounds of possibility. Advances in our understanding of quantum entanglement and the nature of space-time are paving the way for potential breakthroughs. The idea that we could one day teleport objects, or even people, is no longer purely speculative, but a subject of serious scientific inquiry. Could we one day teleport ourselves to distant worlds? The prospect is both thrilling and daunting. The ability to leap across the cosmos in an instant would revolutionize our understanding of space travel and our place in the universe. It would open up new frontiers for exploration and discovery, allowing us to reach places that were previously beyond our grasp. Could Mars, our enigmatic neighbor, be within our grasp, not through years of perilous spaceflight, but through the near-instantaneous leap of teleportation? The red planet, with its mysterious landscapes and potential for life, has long been a target of our exploration efforts. Teleportation could make the dream of setting foot on Mars a reality, transforming it from a distant goal to an achievable milestone. The implications of such a breakthrough are staggering. It would not only change the way we travel, but also how we live and interact with the universe. Colonizing other planets, establishing new societies, and expanding the reach of humanity would become feasible in ways we can only begin to imagine. The potential for growth and discovery is limitless. It would revolutionize space travel, opening up the cosmos to exploration and colonization in ways we can only begin to imagine. The barriers that have kept us confined to our own planet would be shattered, and the universe would become our playground. The possibilities for scientific advancement, cultural exchange, and human evolution are boundless. But this journey into the unknown wouldn't be without its challenges. The technical hurdles are immense, and the risks are significant. We must also consider the ethical implications of such technology. The ability to teleport raises questions about identity, security, and the potential for misuse. These are issues that must be addressed as we move forward. Alongside the technological hurdles lie profound ethical and logistical questions that we must confront before we take our first teleportation leap. How will we ensure the safety and integrity of those who teleport? What regulations and safeguards will be necessary to prevent abuse? These are the questions that will shape the future of teleportation and determine whether this dream becomes a reality. The concept of teleportation has long been a staple of science fiction, from the iconic transporter beams of Star Trek to the jump drives of countless novels. But could this fantastical technology ever become a reality? The answer, tantalizingly, is perhaps. While teleporting a human being remains firmly in the realm of science fiction, the seeds of possibility lie in the strange and counterintuitive world of quantum mechanics. At the heart of this realm is the phenomenon of quantum entanglement, a bizarre connection that can exist between two particles, no matter how far apart they are. When these entangled particles are measured, their fates are intertwined. Measure the state of one and you instantly know the state of the other, even if they're light years apart. This spooky action at a distance, as Einstein famously called it, hints at a deeper interconnectedness in the universe. Could this entanglement be harnessed to teleport information or even matter from one location to another? Some physicists believe it might be possible. The idea is to create a pair of entangled particles, keep one at the sending location, and send the other to the desired destination. By manipulating the state of the local particle, we could theoretically transfer its properties to the distant particle, effectively teleporting it. Quantum entanglement, a mind-bending phenomenon of the quantum world, holds the potential to revolutionize our understanding of the universe. This concept, which Albert Einstein famously referred to as spooky action at a distance, challenges our classical notions of how the world works, and perhaps even pave the way for teleportation. Imagine a future where distance is no longer a barrier, where we can send information or even objects instantaneously across vast expanses of space. But how does this spooky action at a distance actually work? To understand it, we need to delve into the strange and counterintuitive world of quantum mechanics. Imagine two coins, flipped simultaneously. They could both land on heads, both on tails, or one on each. In our everyday experience, the outcome of one coin flip doesn't affect the other. In the quantum world, particles are like these coins, but with a twist. They can exist in multiple states at once, a phenomenon known as superposition. Until we observe them, they exist in a superposition, a state where they are both heads and tails at the same time. This is one of the most perplexing aspects of quantum mechanics. Now imagine entangling these two quantum coins. When particles become entangled, their states become linked in such a way that the state of one particle instantly influences the state of the other, no matter the distance between them. It's like linking them with an invisible thread, so that the outcome of one flip instantly determines the other, creating a connection that transcends space. So that the outcome of one flip instantly determines the other, no matter how far apart they are. This instantaneous connection is what makes quantum entanglement so fascinating and mysterious. No matter how far apart they are, if one coin collapses to heads, the other instantly collapses to tails and vice versa. This is entanglement, an instantaneous correlation that defies our classical intuitions about space and time. The other instantly collapses to tails and vice versa. This is entanglement, an instantaneous correlation that defies our classical intuitions about space and time. While we can't use entanglement to send information faster than light, Einstein's cosmic speed limit still holds. While we can't use entanglement to send information faster than light, Einstein's cosmic speed limit still holds. It does offer a tantalizing possibility for teleportation. Imagine being able to transfer the exact state of an object from one place to another instantaneously. It does offer a tantalizing possibility for teleportation. If we can entangle the particles that make up an object with particles at a distant location, if we can entangle the particles that make up an object with particles at a distant location, we might be able to transfer the object's quantum state, its blueprint, so to speak, instantaneously. This would revolutionize the way we think about transportation and communication. We might be able to transfer the object's quantum state, its blueprint, so to speak, instantaneously. This wouldn't involve physically moving the object through space. This wouldn't involve physically moving the object through space, but rather recreating it at the destination using the teleported information. The implications of such technology are profound, potentially altering the very fabric of our daily lives, but rather recreating it at the destination using the teleported information. The implications of such technology are profound, potentially altering the very fabric of our daily lives. From instantaneous communication to the possibility of exploring distant galaxies, the future holds endless possibilities. While quantum entanglement offers a theoretical framework for teleportation, the practical application of this concept is far from straightforward. The idea of teleporting a person from one place to another instantly is tantalizing, but it involves complexities that go beyond our current technological capabilities. Bridging the gap between theory and reality presents enormous engineering challenges. The machinery required to achieve such a feat would need to be incredibly advanced, capable of handling data at a scale and speed that we can barely imagine today. Imagine having to deconstruct a human being atom by atom with absolute precision. This process would involve not just breaking down the physical structure, but also capturing the intricate details of their biological and neurological makeup. Capturing not just their physical structure, but also their memories, emotions, and consciousness, encoded in the delicate dance of their neural networks, is a task of unimaginable complexity. Each neuron, each synapse, would need to be mapped and recorded. The neural networks in our brains are responsible for our thoughts, memories, and sense of self. Encoding this information accurately is crucial for the teleportation process to be successful. This information would then need to be transmitted instantly to the destination, without any loss or alteration. The data transmission process must be flawless, ensuring that every bit of information is preserved. Where a receiving device would use it to reconstruct the individual down to the last atom, ensuring that their consciousness and sense of self remain intact. The reconstruction process must be as precise as the deconstruction, with no room for error. Ensuring that their consciousness and sense of self remain intact is perhaps the most challenging aspect. The individual must wake up feeling exactly as they did before the teleportation, with all their memories and personality traits preserved. The complexity of this task is staggering. The human body is made up of trillions upon trillions of atoms, each in a specific quantum state. Recording and transmitting this vast amount of information accurately is a monumental challenge. The human body is made up of trillions upon trillions of atoms, each in a specific quantum state. The sheer volume of data that needs to be processed is mind-boggling. Each atom and molecule must be recorded in its exact quantum state. Any deviation could result in errors that might have catastrophic consequences for the individual being teleported. Accurately recording and transmitting this vast amount of information, while ensuring that no errors occur during the process, would require computational power and energy resources far beyond our current capabilities. The data centers needed for such a task would be immense. While ensuring that no errors occur during the process, the integrity of the data must be maintained at all times. Any corruption or loss of data could result in incomplete or incorrect reconstruction, would require computational power and energy resources far beyond our current capabilities. The energy demands alone would be astronomical, requiring new advancements in energy production and storage. Moreover, the ethical implications of such a procedure are profound. What happens to the original during the teleportation process? Is the reconstructed individual truly the same person or simply a copy? These questions raise significant ethical and philosophical concerns. What happens to the original during the teleportation process? Is the reconstructed individual truly the same person or simply a copy? These questions raise significant ethical and philosophical concerns that must be addressed. Is the reconstructed individual truly the same person or simply a copy? The concept of identity and consciousness is at the heart of this debate. If the original is destroyed in the process, can we truly say that the person who emerges on the other side is the same? Despite these challenges, the allure of teleportation remains a powerful motivator for scientific exploration. The potential benefits are enormous, from instant travel across the globe to new ways of exploring space. Just as the impossible dream of human flight eventually gave rise to soaring airplanes and powerful rockets, the pursuit of teleportation could lead to breakthroughs in quantum computing, information technology, and our understanding of the fundamental nature of reality. The pursuit of teleportation could lead to breakthroughs in quantum computing, information technology, and our understanding of the fundamental nature of reality. These advancements could have far-reaching implications for many fields of science and technology, and our understanding of the fundamental nature of reality. The quest for teleportation could unlock new insights into the very fabric of the universe, revealing secrets that have eluded scientists for centuries. The journey may be long and arduous, filled with obstacles and setbacks, but the potential rewards are too great to ignore. The pursuit of teleportation is not just about achieving a technological marvel, it's about pushing the boundaries of human knowledge and capability. But the potential rewards are too great to ignore. The dream of teleportation continues to inspire scientists and engineers, driving them to explore new frontiers and challenge the limits of what is possible.